Moving on to section 2.6. This talks about correlation and best fitting lines. First of all, definitions. Scatter plot. A scatter plot is a graph of a set of data pairs, x, y, which basically means it's just a graph of points. Okay, there's no lines whatsoever in a scatter plot, it's just points. There's positive correlation if y increases as x increases. That means that the dots are going to be going in an upward direction. Assume those are dots. Negative correlation is y decreases as x increases. So think of the x-axis. As x is getting bigger, y is falling. So you see that from left to right, those points are going in a downward direction. Relatively no correlation is when there's no pattern. I've just got a bunch of dots all over the place. They don't look like they're going up or down. Take a look at these. First graph, is there positive, negative, or no correlation? A good rule of thumb, you could take those points and draw an oval around them. And then what's this oval doing? It's not really a perfect oval, but what is this oval doing? From left to right, it's going down. So this would be a negative correlation. Moving over to this one. What does it look like is happening here? Is that oval going up or down? It's not doing anything. It's really just kind of a straight oval. It's almost horizontal. So that one would be relatively no correlation. This last one, it does have a lot of dots kind of going all over the place, but if you take an oval around it, you can see that from left to right, this is going in an upward direction. So this one would be positive correlation. A real-life situation, broccoli consumption. The table shows the per capita consumptions of broccoli in pounds for the years 1980 through 1989. We're going to draw a scatter plot for the data. Notice it says, let T represent the number of years since 1980. So that means that 1980 is going to be our year 0. And notice, if you look at the graph here, each of these blue lines is 0.2. Okay, so, and notice we got a little squiggly because we started at 1 over on the vertical axis. So we were going to graph the point 0, 1.6. So that would be a point, right about in here. And then 1981 would be year 1, and then we're going to go up to 1.8 and put a dot. Year 2, 1982, goes up to 2.2. Year 3 goes to 2.3. That's going to be kind of in the middle of these here. 1989 goes up to 4.5. And now you have a scatter plot. Okay, that's how you start your scatter plot. Again, it's really just a bunch of points. Now your next rule of thumb, and for this one I think it's pretty easy to see about where the line should go. If you wanted to draw an oval around these dots, you could do that to find out where the line should fit. Now if I take a line, I'm going to estimate here, and everybody's line is going to be a little bit different. Nobody's is going to be exactly the same. But I'm going to take a look at this line, and I need to decide, do I have about the same number of points above the line as below the line? Looks like it could go just a little bit further down. So that right there looks like a pretty decent line. Again, everybody's line is going to be a little bit different than anybody else's, but our equation should still be fairly close. So now the next step is to approximate the best fitting line. This is where some people get confused sometimes. When it says approximate the best fitting line for the data, some people just assume that drawing in the line is good enough. However, when it says approximate the best fitting line, they're looking for an equation. So the next step would be to find 2 points on this line that you can read really, really well. Like, for example, this point right here, for me, looks like it's connected very nicely. So I'm going to use that point. Notice it's not a point that was already on the graph. It's just one that I notice I can read really, really well. The next point, now this point is one of our original points. I'm going to go ahead and use it because it looks like it's crossing that line at a very nice point. So now we take those 2 points. This is the point 2, 2.2. Okay, so I'm going to use that point. And then this point over here is 9, 4.2. Now another really good rule of thumb when finding the 2 points, try to find 2 points as far away as possible. If you decide to pick 2 points that are really close to each other, your equation of your line is not going to be as best fitting as it could be. Okay, so our next step now, I'm going to do some of the work up here just to make sure I have enough room. The next step is to come up with the equation. Well, the first thing we need to do, if you think about, remember back to when you're given 2 points, the first thing you need to do is find the slope. So that's what I'm going to do. I'm going to try to find the slope. So when I do that, remember you take y minus y, so it's going to be 4.2 minus 2.2 over x minus x. Remember, if you start with this 4.2, you need to start with the 9. So I'd go 9 minus 2. So my slope, 4.2 minus 2.2 is 2. 9 minus 2 is 7. My slope is 2/7. And now if you think back, we need to go back to our equation y minus y1 equals m times x minus x1. So think about that equation. I'm going to plug in. I'm going to go ahead and use this as my x1, y1. So when I go to plug this in, it's going to be y minus 2.2 equals m, my slope is 2/7, times x minus 2. We're going to have some fun fractions in here. So I've got y minus 2.2 equals 2/7 x minus, remember to distribute here, 2/7 times 2 is 4/7. So now if I add 2.2 to both sides, y equals 2/7 x minus, actually it's going to be plus. So now if I were going to work out negative 4/7 plus 2.2, I would think of 2.2 as 22/10. And if you think about 22/10 and 4/7, they have a common denominator of 70. I know that 22/10, if I change that to 70ths, it'd be multiplying by 7. So it'd be 154 over 70. And then if I subtract the 4/7, I'd have to change that to 40/70ths. And that's going to be 114 over 70. And that's going to be positive. And if I reduce that then, it's going to end up being 57 over 35. So this final part right down here is going to be my best fitting line. That would be my approximate best fitting line. And then the last question is, if this pattern were to continue, what would the per capita consumption of broccoli be in 2002? Well, when you do this, I'm not going to do this whole thing for you, but just so that you know, remember we started with 1980 as year 0. So the year 2002 is going to be 22. So what you need to do for this is think X is 22, and then take that and plug it into the equation that you got to estimate the per capita consumption of broccoli in 2002. And that's a real life situation of a scatter plot and approximating its best fitting line.